You know the feeling. You turn off the nice, smooth pavement, and all of a sudden, your entire car starts shaking itself to pieces. We're talking about those infamous washboard roads. But what if I told you that bone-jarring, tooth-rattling nightmare isn't a mistake at all? What if it's actually a perfect, spontaneous example of physics just doing its thing?
I mean, it's that relentless, rhythmic thump, thump, thump that makes you grip the steering wheel for dear life. It feels almost intentional, like someone designed it specifically to be the most annoying thing on the planet.
But that's the crazy part. They aren't designed at all. Those perfectly spaced, incredibly irritating ripples are what's called a self-organizing pattern. You can have a perfectly flat dirt road, but under the right conditions, it will create these bumps all by itself. So how on earth does that happen? Well, that's the riddle we're going to solve today. How does this perfect, ordered pattern just emerge out of nowhere on a simple dirt road? The answer, it turns out, is this really fascinating mix of speed, rhythm, and, well, the dirt itself.
This is what was so baffling for years. You can literally take a road grader, smooth a road out so it's like a sheet of glass, and then after just a handful of cars drive over it, bam, the washboard is back. It's a natural instability, almost like the road wants to be bumpy.
So let's peel back the first layer of this mystery. The first big clue isn't actually in the road, it's right there on your dashboard, on your speedometer. It all comes down to a trigger: speed. 5 miles per hour. That's the magic number. In physics, they call it the critical velocity. It's the exact tipping point where the whole game changes. If you drive below this speed, your tire just kind of rolls over and presses the dirt down, keeping things nice and flat. But the moment you go faster, everything changes. And you can see that switch right here. Below that speed, no problem. The road just takes the hit. But go above it, and the physics flips. The bouncing forces from your car's wheels start to overwhelm the dirt's ability to stay put. And that bouncing is what actually starts to carve and sculpt the road. And this brings us to the absolute core principle at play here: resonance. You already know what this is, even if you don't use the word. Think about pushing someone on a swing. You don't just shove them whenever. You push at the exact right moment, matching the swing's natural rhythm. And that's what makes it go higher and higher. It's the exact same thing happening between your car and the road. So here's the play-by-play. Your car's tire and suspension have their own natural bouncing frequency. When your tire hits just one tiny little bump in the road at speed, it bounces up and then comes down. If the timing of that bounce happens to line up with the next little imperfection, it lands even harder, digging a deeper hole and kicking a little pile of dirt forward. Then the next car comes, does the exact same thing, and the next, amplifying the pattern until it's locked in. Okay, and this is where it gets really, really cool. This whole thing, it's not just some weird quirk of dirt roads. The basic idea of a bouncing object moving over a surface that can be changed, that's a fundamental pattern-forming process that you see all over the place, in nature and in technology. Seriously, once you understand this bouncing mechanism, you start to see it everywhere. The same physics that's trying to shake your car apart is also responsible for sculpting the world in some other really surprising ways. Just think about it for a second. Those giant bumps on a ski slope, moguls, that's just skiers bouncing and turning, carving the same kind of pattern into the snow. The weird repeating wear patterns you see on solid steel railroad tracks, same principle, just with a much, much heavier train. Ripples in the sand at the beach, even the way a stone skips across the water. It's all just a different version of the exact same resonant, bouncing instability. So we've got the force, that bouncing tire, but that's only half of the story. You also have to look at the surface it's acting on. The condition of the dirt itself is the other critical piece of the puzzle, because not all dirt is created equal when it comes to making washboards. It's kind of a Goldilocks problem, right? If the soil is totally bone dry, there's nothing holding it together. A tire hits it, and it just puffs up into dust. It doesn't really get displaced into a new shape. On the flip side, if it's way too wet, the clay that's supposed to act like glue turns into a lubricant, and the whole thing just becomes a soupy mess. So for washboarding to really take hold, the conditions have to be just right. You need enough of that clay binder to hold the gravel together, but also just enough moisture to make it soft and plastic. Soft enough to be sculpted by those bouncing tires. In fact, a slight excess of that binder material is often the #1 culprit.
Okay, so we understand the physics now. We've got a bouncing force, we've got a surface that's ready to be shaped. So the million-dollar question is, can we stop it? How do you actually fight back against this fundamental force of physics?
Well, the first line of defense is just smart road design, and it's pretty much all about controlling water. You need a crowned surface so the water runs off to the sides, you need well-maintained shoulders and clean ditches to carry that water away from the road, and of course, it all starts with using good quality gravel with the right amount of binder so the road doesn't get too soft to begin with.
The modern approach is actually getting pretty high-tech. I mean, for decades, the only answer was to scrape the road flat with a grater, but you and I both know the ripples always come back. But today, there are advanced chemical stabilizers that can literally react with the clay particles in the soil. They create a denser, harder base that physically resists being deformed, basically fighting the physics at a molecular level.
But okay, let's be real. You're probably not a road engineer. So what can you do right now in your own car to make that ride just a little bit smoother? The answer is incredibly simple, and it's all about turning your tire into a better shock absorber. 70%. Just look at that number. By dropping your tire pressure from what you use on the highway down to something like 25 or 30 psi, you can cut down the vibration you feel from washboards by as much as 70%. That's a huge difference.
And here's the simple reason why it works. Lowering the pressure lets the sidewall of your tire flex and bend more. It also makes the part of the tire that's actually touching the ground, the contact patch, a little bit longer. That combination means the tire itself can soak up the little bumps before they ever even get a chance to jolt your suspension. And that breaks the whole resonance cycle we talked about.
So the next time you find yourself rattling down a dirt road, maybe instead of just cursing on the potholes, you can take a second and appreciate the incredible universal physics that's happening right underneath your tires. It's not really a mistake or a failure. It's a pattern etched into the world by motion and rhythm. It's a pretty cool reminder that even inside something as annoying as a bumpy road, there's a really fascinating story about how the world works, just waiting to be understood.